Okay, let's look at how a hormone is going to act on its target cell. Let me get back to that slide. There we go. They're going to bond to a receptor on either of two locations. One would be the extracellular receptor on the outer surface of the cell membrane, and the second possibility is an intracellular receptor, that being usually found either in the cytoplasm or in the DNA. Now, the water-soluble hormones, which we talked about first previously, this would be the amino acid derivatives as well as the peptide hormones. These hormones cannot move easily through the cell membrane, so they require extracellular receptors to bind to. Typically in this situation then, the hormone acts as a first messenger. I apologize for the waywardness of my PowerPoint here. Okay, I was just trying to get my pens and they ran away from me on the last slide. Okay, so we've got the first messenger right here. This is usually the hormone that binds to the receptor. Now, this first messenger is going to cause a reaction that produces a second messenger, which might inhibit or activate an enzyme or cofactor. But regardless of how it works, it is going to alter the activities of the cell. If you look at some of the effects, it might open ion channels, might activate enzymes, reduce enzyme activity, and over here has a whole different process using the calcium and calcium channels. That's quite interesting by itself. Regardless of what the action is going to be, the receptor that is bonded to its hormone is going to activate a G protein. This G protein is the link between the first and second messengers. One of the possible activities from a water-soluble hormone action is amplification. Amplification occurs when this single hormone is going to create thousands of second messengers. I drew a couple more cyclic AMP to illustrate that it's going to do multiple second messengers. One of the other things that we need to take into consideration right now is how a target cell responds when we have varying concentrations of hormones in the blood. Downregulation. In downregulation, the cell reduces the number of receptors in the cell membrane. This usually happens when hormone levels are high, and it will reduce the sensitivity of that hormone to it will reduce the sensitivity of that target cell to that hormone. Upregulation occurs when there are lower levels of hormone. In this case, we are going to increase the number of receptors so that the target cell is more responsive to low levels of hormone.